Similar triangles. Pythagoras was an Ionian Greek philosopher, mathematician, and founder of the religious movement called Pythagoreanism. Pythagoras made influential contributions to philosophy and religious teaching in the late 6th century BC, before Christ. He is often revered as a great mathematician, mystic, and scientist, but he is best known for the Pythagorean theorem, which bears his name. Now we are learning from these similar triangles. The learning outcomes of this chapter is similar figures, similar polygons, regular polygons, scale factor, similarity of triangles, basic proportionality theorem, that is called Thales theorem, converse of Thales theorem, dividing a line segment in the given ratio, criteria for similarity of triangles, angle, 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 side, 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 and side angle side rules, areas of similar triangles, Pythagoras theorem, this is called Bauduin theorem, and statement, negation, converse, and proof by contradiction. We are going to learn all these chapters, all these geometrical figures which have the same shape with all parts in proportion are called similar figures. And the heights and distances of distant objects can be found using the principles of similar figures. Two polygons with the same number of sides are said to be similar if their corresponding angles are equal and their corresponding sides are in proportion. A polygon in which all sides and all its angles are equal is called the regular polygon. Now square. This is a square, and equilateral triangle, regular pentagon, and regular hexagon. The ratio of the corresponding sides is refers to as scale factor or representative factor. All squares are similar. All circles are similar. All equilateral triangles are similar. All regular polygons of the same number of sides, such as equilateral triangles and squares, etc., are similar. Two congruent figures are similar, but two similar figures need not to be congruent. A square ABCD and a rectangular PQRS are of equal corresponding angles, but their corresponding sides are not in proportion. The square ABCD and the rectangular PQRS are not similar. This is a square ABCD and PQRS is the rectangular. The both are not similar because the sides is not proportion. AD is proportion to SPS, but AB is not proportion to PQ. So that's why these two figures are not similar. And look at this. The corresponding sides of a square ABCD and a rhombus PQRS are equal, but their corresponding angles are not equal, so they are not similar. Now look at here. ABCD is a square and PQRS is a rhombus. The sides are equal. The corresponding sides are equal. Here AB equal to PQ, BC equal to QR, and CD equal to RS, and AD is equal to PS. But the angles are not equal. Angle A is not equal to angle P. That's why these both are not similar figures. If a line is drawn parallel to one side of a triangle intersecting the other two sides at two distinct points, then the other two sides are divided in the same ratio. That means if you draw a line, this is a line drawn parallel to BC. A line DG is drawn parallel to BC. And then this line That means D is a point at AD and DB, the ratio of AD and DB, and this side AE and EC, the ratio of these two sides are that divides in the same ratio. This D is divides AD and AC in the same ratio. That means in triangle ABC, the DE and BC are parallel. Then AD by DB is equal to AE by EC. This is called basic proportionality theorem or Thales theorem. If a line divides any two sides of a triangle in the same ratio, if a line any two sides AB and AC or AB and BC or BC and CD, a line divides, for example here AB and AC two sides, this DE is divides in the same ratio AD by DB equal to AE by EC, then the line must be parallel to the third line. This line must be parallel to third line. Third line means this is the third one. In ABC, a line L in ABC, a line L intersecting AB in D and AC in E. A line in this triangle, ABC triangle, a line means this is a line L, this is a line intersecting AB at D and AC at E, such that AD by DB is equal to AE by EC. Then that L is parallel to BC. This line is parallel to BC. This is converse of Thales theorem. This is converse of Thales theorem. Two triangles are similar if their corresponding angles are equal. Two triangles are similar, their corresponding angles are equal. That means, for example, it is ADE is a triangle and ABC is another triangle. The corresponding angles D and B are equal, and again E and this C is also equal. Their corresponding sides are in the same ratio. Their corresponding sides, that means AD, AD, AD and AB. This AD and AB, like AE and AC and DE and BC, the corresponding sides ratio also equal. That means AD by DB, AD by AB, AD by AB is equal to, we can write AE by AC is equal to DE by BC. Their corresponding sides are in the same ratio. If in two triangles corresponding angles are equal, corresponding angles, for example, angle A equal to angle T, angle B equal to angle E, angle C equal to angle F, corresponding angles are equal, then their corresponding sides are in the same ratio, are proportional, and hence the two triangles are similar. Corresponding angles, that A equal to D, angle A equal to D, angle B equal to E, angle C equal to F. Then the corresponding sides, that AB by DE and BC by EF and AC by DF, these ratios are equal. When these ratios are equal, then the ABC and DEF are similar triangles with respect to angle. Both are similar triangles with respect to angle. If in two triangles, the sides of one triangle are proportional to the If in two triangles, sides of one triangle are proportional to the sides of other triangles, then their corresponding angles are equal and hence the two triangles are similar. If in two triangles, this ABC and DEF, sides of one triangle are proportional, that means sides of one triangle, this is AB and DE, for example, let AB and DE, these two sides are proportional to the sides of other triangle, this one is other triangle, then their corresponding angles are equal. Corresponding angles are, for example, A and B, A, D, B, E are equal and hence the two triangles are similar. Then these two triangles are similar. Now look at here, AB by DE equal to, from these two triangles, AD by DE equal to BC by the sides, corresponding side is EF, BC by EF, and AC corresponding side is GF. Then this implies angle A is equal to angle D, angle B equal to angle E, and automatically the third angle should be equal, angle C equal to angle F. Hence this is the triangle ABC is similar to triangle DEF because the sides, all the sides are equal, the corresponding sides are proportional. If two angles of a triangle are equal to two corresponding angles of another triangle, then the two triangles are similar. If two angles of a triangle are equal, two angles, that means angle A and angle A equal to angle D, angle B equal to angle E. The two angles are equal and automatically we can write third angle is also equal, angle C equal to angle F. This is by angle sum property. The sum of angles in a triangle is equal to 180 degrees, up to 180. So angle A plus angle B plus angle C equal to 180. So A and B, D and E equal, automatically the C is equal to F we can write. Triangle ABC is similar to triangle DEF, angle rule. If one angle of a triangle is equal to one angle of the other triangles and the sides including these angles are proportional, then the two angles are similar. That means if one angle of a triangle is equal to one angle of the other triangle, that means angle A equal to angle D. One angle of a triangle is equal to one angle of other triangle. Then the sides including these angles are proportional. These angles are proportional. That means AB by DE equal to AC by DF. These sides are proportional. One angle is same, the sides, corresponding sides are proportional, then the two triangles are similar. Then triangle ABC is similar to triangle DEF. This is side angle side rule. The ratio of the areas of two similar triangles is equal to the ratio of the squares of their corresponding sides. The ratio of area of two similar triangles, this is ABC triangle, its area is the DEF area is equal to the ratio of their sides of their corresponding sides. Their sides, for example, AB square by DE square, we can write the area of ABC and DEF, the ratio of these two triangles is equal to the corresponding sides, squares of the corresponding sides ratio AB square by BDE square and BC square by EF square, BC square by EF square also equal to AC square by DF square, AC square by DF square. If a perpendicular is drawn from the vertex containing the right angle of a right angled triangle to the hypotenuse, then the triangles on each side of the perpendicular are similar to one another and to the original triangle. Also, the square of the perpendicular is equal to the product of the lengths of the two parts of the hypotenuse. Now look at here. If a perpendicular is drawn from the vertex, a perpendicular line is drawn from vertex B to hypotenuse, that is AC. The biggest side in a triangle is called hypotenuse. Containing the right angle of the right angle triangle. It is a right angle triangle. ABC is a right angle triangle to the hypotenuse. Then the triangles on each side of the perpendicular, and that each side of the perpendicular, this one and this one, that means ABD triangle and BDC triangle, and are similar to one each other and the original one. The ABD is similar to ABC and BDC also similar to ABC. Also, the squares of the perpendicular is equal to the product of the lengths of the two parts of the hypotenuse. That means the BD square equal to, we can write AD into DC. BD square is equal to AD into DC. Now, in triangle ABC, angle B is 90 degrees. Angle B is here 90 degrees. And BD is perpendicular to AC. Angle BD is perpendicular to AC. Then, triangle ADB is similar to BDC is similar to original triangle ABC, and BD square is equal to AD into DC. Pythagoras theorem. In a right angle triangle, the squares of hypotenuse is equal to the sum of the squares of other two sides. What is the Pythagoras theorem? In a right angle triangle, the square of hypotenuse is equal to the sum of the squares of other two sides. That means BC is the hypotenuse because it's the biggest side of a triangle, right angle triangle, and BC square equal to the square of hypotenuse. This BC square is equal to the sum of other two sides, AB square and AC square. Sum means plus AC square. So, in a right angle triangle ABC, angle A is 90 degrees here. Angle A is 90 degrees. Then AB square plus AC square is equal to BC square. In a triangle, if square of one side is equal to the sum of squares of the other two sides, then the angle opposite to the first side is right angle. What is the meaning of? the square of one side, that is AC square, for example, the square of one side is equal to the sum of squares of other two sides. That means other two sides AB and BC. Sum of other two sides square and sum BC square. AC square equal to AB square plus BC square. Then the side, the first side means AB, opposite angle is B. This angle is always right angle. That means AC square is equal to AC is hypotenuse, big one. AC square equal to AB square plus BC square. Then angle B is equal to 90 degrees. This is converse of Pythagoras theorem. Baudayan theorem about 800 before Christ. The diagonal of a rectangle produces itself the same area as produced by its both sides, lengths and breadths. In a rectangle ABCD, area produced by the diagonal AC, the area produced by the diagonal AC, this is area, this side and this side, equal to AC into AC, AC into AC, AC square, or area produced by the length equal to AB into BA, that is AB square, and area produced by the breadth BC, BC and CB, BC and CB, that is BC square. Hence this AC square is equal to AB square plus BC square. A sentence which is either true or false but not both is called a simple statement. A statement formed by combining two or more simple statements is called a compound statement. A compound statement of the form if then is called conditional implication. A statement obtained by modifying the given statement by not is called the negation. Now this is the first theorem, basic proportionality theorem or Thales theorem. Proposition: if a line is drawn parallel to one side of the triangle to intersecting the other two sides in distinct points, then the other two sides are divided in the same ratio. What is given? A triangle ABC in which the DE is parallel to BC and DE intersects AB at D and AC at E. ఇక్కడ మనము ఒక ట్రయాంగిల్ తీసుకున్నాం. ఈ ట్రయాంగిల్లో డిఈ అనేది బీసీకి ప్యారలల్గా ఉన్నది. అలాగే ఈ డిఈ అనేది డి అనే పాయింట్ ఏబిని డి వద్ద ఇంటర్సెక్ట్ అయింది. అట్లాగే ఏసీని ఈ వద్ద ఇంటర్సెక్ట్ అయింది. అంటే ఏబి సైడ్ పైన డి ఏసీ సైడ్ పైన ఈ అనేవి ఉన్నాయి. నౌ ద కన్స్ట్రక్షన్ జాయిన్ బిఈ అండ్ సిడి and draw lines. EF is perpendicular to AD and DG is perpendicular to AC. తర్వాత మనం ఏం చేస్తాం కన్స్ట్రక్షన్లో అంటే మనము మొదటగా ఈ ట్రయాంగిల్ బిని ఈని కలిపేద్దాం. ఈ ప్యారలల్ లైన్ ఉంది కదా, ఈ ప్యారలల్ లైన్లో వెర్టిసెస్ ఏవైతున్నాయో ఈ బిను ఇక్కడ ఈని కలుపుదాం. అట్లాగే సిని డిని రెండును కలిపేస్తున్నాం, జాయిన్ చేసాం. తరువాత ఈ ఏసీకి ఒక పర్పెండిక్యులర్ లైన్ డి వద్ద నుంచి గీయాలి, దట్ ఈస్ డీజీ. అట్లాగే ఏబీకి ఒక పర్పెండిక్యులర్ ఈ వద్ద నుంచి గీయాలి, దట్ ఈస్ ఈఎఫ్. ఏబి పైన ఈఎఫ్ అనే పర్పెండిక్యులర్ లైన్ లేదా ఏడి పైన అనుకున్నా పర్లేదు. ఏఈ పైన కానీ ఏసీ పైన ఒక పర్పెండిక్యులర్ లైన్ దట్ ఈస్ డీజీ గీయాలి. ఇప్పుడు ఈ పర్పెండిక్యులర్ లైన్ ఏదైతే ఈఎఫ్ ఉన్నదో ఇది ఏబికి పర్పెండిక్యులర్ లైన్ అవుతుంది, ఏడీకి పర్పెండిక్యులర్ లైన్ అవుతుంది, ఏబికి కూడా పర్పెండిక్యులర్ లైన్ అవుతుంది. అట్లాగే డీజీ అనే పర్పెండిక్యులర్ లైన్ ఏఈకి ఏసీకి కూడా పర్పెండిక్యులర్ లైన్ అవుతుంది. వాట్ ఈస్ ప్రూఫ్? ఏం నిరూపించాలి మనం? ఇన్ triangle EAD, this is a triangle, and EDB, this is another triangle. Here, as EF is perpendicular to AB, therefore EF is the height for both triangles EAD and EDB. EF is perpendicular to the this AD and DB also. Now the area of EAD triangle, this one, E triangle తీసుకుందాం. We know that half into base into height. What is half into base? ఏంటిది ఇక్కడ? AD, base is AD and the height is EF. So area of EAD equal to 1/2 base into height, that equal to 1/2 AD into EF. అలాగే కింద ఉన్నటువంటి ఇదే బేస్తో ఉన్నటువంటి మరొక ట్రయాంగిల్ ఏంటిది? ఇది BDE అనే ట్రయాంగిల్ తీసుకుంటే దీని ఏరియా కూడా, దీని యొక్క బేస్ వచ్చి BD అవుతుంది, దీని యొక్క హైట్ వచ్చి EF అవుతుంది. ఫ్రమ్ ఏరియా ఆఫ్ ట్రయాంగిల్ EDB is equal to 1/2 into base into height, that equal to base is DB and height is EF. From this 1 and 2 ఈ రెండింటిని ఒకదాన్ని ఒకటి డివైడ్ చేద్దాం. ఏరియా ఆఫ్ ట్రయాంగిల్ EAD by ఏరియా ఆఫ్ ట్రయాంగిల్ EDB is equal to 1/2 AD into EF by 1/2 DB into EF. But here 1/2 cancelled, EF cancelled. We will get AD by DB. This is equation number 1. Area of triangle EAD and area of triangle EDB is equal to AD by DB. Number 1. And the second one, same, we can take right this side. Similarly, we can show that this area of ADE and DEC, these two, from these two triangles, and area of ADE, the DG is perpendicular to AE. From right side, area of ADE, triangle AD is equal to 1/2. What is base? Base is AE and height is DG. You can write height is DG. And the area of DEC, from DEC, area of triangle DEC is equal to 1/2 height into base. Base is CE and height is DC. Base is CE into height is DG. From these two, if we divide these two, we will cancel 1/2 and 1/2, DG and DG. We will get this from these two triangles, AE by CE. Similarly, the area of EAD by area of DEC లేదా ECD equal to AE by EC. This is number 2. From 1 and 2, this is 1 and 2, we will get because here the area of DE, ADE and DEB, the ratio of these two is equal to ADE by DEC. Both are same, because that the triangle BDE is, the base is DE, and DCE base is also same, DE. In the parallel, these two vertices in the same parallel line, DE and BC both are parallel lines. These triangles are with base DE, two triangles are there, so its area is also equal. అర్థమైంది కదా. మనకి రెండు ప్యారలల్ లైన్ మధ్య ఉన్నటువంటి ట్రయాంగిల్స్, ఒకే బేస్తో ఉన్నటువంటి ట్రయాంగిల్స్ ఏవైతే ఉంటాయో, అంటే డిఈసి కానీ అట్లాగే సేమ్ బేస్, అదే ఈ ప్యారలల్ మధ్యలో డిఈబి అనే ఈ ట్రయాంగిల్ ఉంది. ఒకే బేస్ ఉన్నది కాబట్టి ఈ రెండిటి యొక్క ఏరియా సమానంగా ఉంటుంది. కావున ఈ ఏడిఈ అనేది రెండిటికి కామన్గా ఉంది కదా, ఏడిఈ అనేది రెండిటి కామన్గా ఉంది కాబట్టి ఇప్పుడు ఈ మొదటిది ఇది దీని ఏరియా యొక్క నిష్పత్తులు రెండు కూడా మనం ఈక్వల్గా రాసుకోవచ్చు. ఫ్రమ్ 1 and 2 ADBE and AECD are on the same base DE, and between the same parallel lines DE and BC we have the area of DBE is equal to the area of ECD. ఈ రెండు సమానంగా రాసుకున్నాం. Hence from 1 and 2 we will get AD by DB is equal to AE by EC. This is the theorem number 1. That means if you draw a parallel line to BC, that is DE, it divides in the same ratio. AD by DB is equal to AE by EC. This is the theorem number 1.